class. This is Ma'am Elsie, and for today's lesson, you will be learning about real numbers. So to fully understand real numbers, first, let's take a look at the bigger picture, beginning with numbers. Anything that you could possibly think of are considered numbers. But some numbers belong to real numbers and some numbers belong to imaginary numbers. Okay, let's have an example for imaginary numbers. This time, let's have the square root of -4. Now, can you think of a number that when you square it, the answer is -4? You're right. There's no such number that when you square it, the answer is -4. That's why it belongs to imaginary numbers. And the concept of imaginary numbers, we will separate the positive factor and the negative factor. So for our example, the square root of -4, we can factor it out as -1, the square root of -1, and the square root of +4. So we will get the answer. So the square root of +4 is 2, and the square root of -1 is the small italic letter I. So therefore, our answer is +2i. Okay, this time, let us study the world of real numbers. So the hierarchy chart of the set of real numbers shows the relationship of the different types of numbers. Its subsets include rational numbers and irrational numbers. So now, let us define the following terms that you need to remember. The first one is real numbers. Real numbers are union of rational numbers and irrational numbers. So now, let's proceed to rational numbers. So rational numbers are numbers that can be expressed as a quotient of two integers a over b. A is our numerator and our b is our denominator. And remember, the denominator should not be equal to 0 so that it will not make our expression undefined. This set includes fractions and repeating or terminating decimal numbers. Example, we have -1. Remember, when we have integers, whether it is positive or negative, it has always the denominator equal to +1. So when we have -1, we have the denominator also as +1. So it can also be expressed as a over b. The next example is 1/4 or 1/4. When we divide 1 divided by 4 using a calculator, the result is 0.25. And remember, as we can see, the answer 0.25 is a terminating decimal. Therefore, it is considered as rational number. Another example, we have 2/5 or 2/5. Using a calculator again, the result is 0.4. And the answer is a terminating decimal. Another example, we have 1/3 or 1 divided by 3. Using a calculator, the result is 0.3333 and it continues forever. So that is an example of repeating decimal and it is also considered as rational number. Lastly, we have the square root of 4. The answer to the square root of 4 is either +2 or -2. And again, these are integers and integers as always have a denominator equal to 1. So therefore, it can also be expressed as a over b. On the contrary, we have these irrational numbers. Irrational numbers are numbers that cannot be expressed as a ratio of two integers a over b. This set may be represented by a decimal that neither repeats nor terminates. Example, we have the square root of 11. So when we use the calculator, the square root of 11 results to 3.31624,790 ... so on, and it continues forever. That means there is no repeated number and there is no pattern at all, and it does not terminate. That is why it is an example of a rational number. Another example is the decimal 9.9498743. Again, it continues forever. As you can see with the decimal places, there is no repeated number and that does not terminate. That means it is a rational number also. Lastly, we have the symbol pi. Remember, in our practice, we always use 3.14, but in actual, it has a long decimal places. It has 3.14, 1, 5, 9, 2, 6, 5, 3, so on and so forth. As you can see, in the decimal places, there is no number that is repeatedly calculated, and at the same time, there is no pattern. That is why pi is also considered as a rational number. Under the rational numbers, we have these integers, whole numbers, and counting numbers. So let us define first the integers. Integers are the union of the set of whole numbers and the negative of counting numbers. Example, we have -2, -1, and all other negative numbers, 0, +1, +2, and all other positive numbers. The next one is the whole numbers. Whole numbers include the natural numbers and the 0. So what are the natural numbers? We have +1, 2, 3, including 0. While the counting numbers or the natural numbers, it starts with +1, 2, 3, 4, so on and so forth, and all other numbers that we use in counting things. So to further explain the relationship among the subsets of real numbers, a Venn diagram is shown at the right. As you can see, we have this universal set of real numbers, and then under the real numbers, we have the two circles. The first one is the rational numbers, and the other one is the irrational numbers. So under the rational numbers, we have these integers. We also have these whole numbers, and under the whole numbers, we have the counting numbers. And now let us deepen our understanding about rational numbers. So in arranging rational numbers, there are some instances that the real numbers arranged in ascending order or descending order. So to do that, here are the methods to remember. First, when the denominators are the same, the fraction with a bigger numerator has a greater value. For example, we have this 1/4 and 3/4. So we are going to compare which between the two rational numbers is greater and which one is or has smaller value. Since the given rational numbers have the same denominator or simply similar fractions, then we can directly compare them through their numerators. So their numerators are 3 and 1. So the greater is 3. Therefore, we can conclude that 3/4 is greater than 1/4. Second, when the numerators are the same, the fraction with smaller denominator has a greater value. Let's have an example. 7/4 and 7/3. As you can see in our example, they have the same numerators, which is 7, while the denominators are 4 and 3. So obviously, the fraction with greater value is 7/3, since 7/3 has a smaller denominator, which is 3. So in conclusion, 7/4 is less than 7/3. Okay, the next one is when both numerators and denominators are not the same, then we can use actually two methods. The first one is the LCD to make our fractions similar, and the second one is the comparison property of rational numbers. So okay, let's start with using the LCD method. We have the example 5, 6, and 6/7. As you can see in our example, they have different numerators, 4 and 6. Also, they have different denominators, 5 and 7. Now, the first thing that we're going to find is the LCD, or it stands for the least common denominator. Can you think of a number, that least number that can be divided by 5 and 7? You're right, and that is 35. So after getting our denominator or common denominator 35, next step is to look at the denominators again. So let's go back to the first fraction. We have 4/5. The denominator is 5. Now, what number that can be multiplied by 5 to make it 35? You're right, and that is 7. If we multiply 7 to 5 to make it 35, then we also multiply 7 to the numerator to make it 4 times 7, and it becomes 28. So the fraction now becomes 28 over 35. And now let's look on the second fraction, which is the 6 over 7. Remember, our denominator is 7, and our LCD a while ago is 35. So 7, can you find a number that can be multiplied by 7 to make it 35? Alright, that is 5. So when we multiply 7 times 5, it becomes 35. So if we multiply 5 in our denominator, we will also multiply 5 to the numerator so that it becomes 6 times 5. So 6 times 5 is equal to 30. And now our fraction 6/7 becomes 30 over 35. Okay, let's proceed to the comparison. So we were going to compare right now the 28 over 35 and 30 over 35. So based on their numerators, we can conclude that 28 over 35 is less than 30 over 35. The second method is the comparison property of rational numbers. Say for instance, we have these two fractions. A over C is greater than B over D. If and only if AD is greater than BC. Another one, if A over C is less than B over D, if and only if AD is less than BC. So now let's proceed to the example. We have 5/6 and 2/3. So what we're going to do is just to cross multiply. So the first one, we have to multiply 5 and 3, and that becomes 15. And the other one, we have to multiply 6 and 2, and the result is 12. So to compare which between the two is greater, has a greater value, it is obvious that it is 15. So therefore, we can conclude that 5/6 is greater than 2/3. And now let us arrange real numbers in ascending or descending order using the number line. By the way, what is a number line? A number line is a line that extends in both directions, starting from 0 and going to the right are positive numbers and going to the left are negative numbers. What is the purpose of having a number line? A number line can be used to arrange real numbers in ascending order, and through it, you can visualize its placement. On a number line, if a real number lies on the right of another number, then it is greater than the other real number. However, if a real number lies on the left of another real number, then it is less than the other real number. Okay, let's have an example. How can we arrange the following real numbers 3/4, 2.1, 4 1/2, and -3 in an ascending order? First, we need to draw a number line where 0 is at the center and the positive numbers on the right side and the negative numbers on the left side. Okay, let's plot 3/4. Where can we locate 3/4 in our number line? You're right, it's between 0 and 1. But before that, we need to make sure that it's really located at 3/4. So we need to divide the space into 4 equal parts since our denominator is 4. And we'll just count 1, 2, and 3. Then right there, we have 3/4. As you can see in our picture, in our illustration, the color yellow. The second one is the 2.1. Again, where can we locate 2.1? Yes, it's between 2 and 3. But before that, let's divide
the space into 10 equal parts since it is written in decimal form. So we will just have to count 2.1. 2.1 is the next to 2. So right there, we will put or plot the point 2.1. As you can see in our illustration, the color blue. Let's proceed to 4 and 1/2. This time, we have the whole number and fraction. So we will find it between 4 and 5. Since our fractional part is 1/2, we just have to divide the space into 2 equal parts. So that means 4 and 1/2 is between 4 and 5. So the color green is the point where we can locate 4 and 1/2. And lastly, we have the -3. So all you have to do is to find -3 on the left side part of our number line. And right there, we have the -3, the one that is the color red.
And now, let us practice what you have learned from our discussions by answering the following activities in this digital interactive learning module. Thank you and have fun!